Corporate loyalty programs lock billions of dollars of consumer value inside isolated data architectures. Every airline, hotel, and retail chain operates its own proprietary ledger. The corporate incentive to break these silos is obvious. Enterprises want to plug their stagnant point systems into the interoperable, programmable reward structures of Web3. This model shows the standard approach, migrating corporate points directly onto a blockchain ledger one-to-one. The moment points cross the bridge, the system fails. Tokenizing a loyalty point alters its regulatory classification. The brand assumes severe crypto custody liabilities, turning a marketing tool into a legal hazard. The Sigma BankAi I'm In architecture abandons the direct asset swap. The physical bridge is replaced by a read-only scanner extracting data, not underlying assets. Legacy points remain perfectly stationary on the corporate books, operating purely as eligibility triggers and reward multipliers. This read-only mechanism allows the protocol to issue time-locked, utility-only token airdrops based entirely on verifiable user behavior, bypassing the migration problem altogether. True Web3 loyalty integration requires decoupling the legacy ledger from the token issuance layer. This satisfies the strict compliance requirements of the legal department while delivering the interoperable rewards the end user expects. The foundation of this architecture begins with Layer 1. The airline miles, retail points, or banking rewards stay strictly confined to the private corporate database. This diagram illustrates the interaction with Layer 2, the Lightweight Rewards Oracle API. The Oracle scans the Layer 1 database and translates the user's loyalty status into a string of cryptographic code. The Oracle is configured to look for specific, partner-defined eligibility thresholds. It scans to verify if an account holds 50,000 airline miles or has cleared $5,000 in annual card spend. Once those thresholds are verified, the Oracle packages the resulting data into a Merkle proof, a compact cryptographic structure that confirms the data is accurate without revealing the data itself. The Oracle periodically signs and posts these Merkle proofs directly to the partner's campaign smart contract on the blockchain. The transmitted payload consists exclusively of hashed IDs and eligibility flags. 0 personally identifiable information, and 0 specific point balances ever touch the chain. By restricting the Oracle to a read-only architecture, the enterprise entirely eliminates crypto custody risks while proving the user's value to the broader Web3 network. The data from the Oracle feeds into Layer 3, an off-chain engagement score ledger assigned to each individual user within the I'm In ecosystem. Traditional loyalty models encourage passive hoarding. The Sigma protocol requires active, verified behaviors to extract value. Users engage through specific missions. Watch missions require the user to complete partner financial literacy clips or explainer videos end-to-end. Transact missions demand verifiable on-chain actions, such as connecting a wallet, passing KYC protocols, or depositing funds into a primary wallet. This visualization shows the result of completing those actions. Distinct inputs, like a content view or a KYC approval, generate incremental claim tickets. These tickets feed directly into the user's centralized engagement score. These aggregated claim tickets then directly map to the user's eligibility for utility token airdrops. You cannot claim the airdrop without accumulating the tickets. Token emission operates as a strict behavioral protocol. Tokens are granted precisely when users perform actions mapping directly to the partner's key performance indicators. Completing a verified mission yields a standard base reward of utility tokens for any user. The dynamic equation here reveals the core mathematical mechanic of the ecosystem. The user's legacy corporate points act strictly as point-weighted multipliers on that base reward. High-balance corporate customers, like airline elites or premium cardholders, enter the system qualifying for the highest multiplier tiers. Their past loyalty scales their future rewards. Conversely, new or low-balance users enter at the baseline 1.0 tier, earning exactly the base reward without any accelerated velocity. This directly aligns with established loyalty psychology. Existing VIPs feel an instant status upgrade within Web3 because their hard-earned legacy points carry tangible weight. Legacy points dictate a user's earning velocity. The customer experiences a massive perceived upgrade, while the corporate balance sheet remains entirely isolated from crypto liability. The final governor of this token distribution is the campaign smart contract. As shown in this diagram, the smart contract vault executes a programmed split. It releases an immediate 10% allocation into an upfront bucket, ensuring the user has instant access to basic ecosystem utility. The remaining 90% is locked into a linear vesting timeline. This balance unlocks stepwise, strictly gated by the user continuously hitting monthly engagement metrics like repeat views or transaction volume. If a user breaks their engagement streak, unvested tokens are intercepted. The contract mathematically redirects them back to the campaign pool or community treasury. To protect distribution logic, the contract relies on hard-coded anti-Sybil filters, enforcing quality over sheer quantity. The system checks for verified KYC, minimum wallet age, and consistency of transactional behavior before authorizing major reward tiers. Bot networks cannot replicate these signals. Publishing precise distribution rules transparently on-chain builds immediate community trust. Everyone understands parameters of the game. Programmable smart contracts take the standard airdrop, typically an exploitable one-time extraction event, and force it to operate as a sustainable, gamified retention engine. All of these mechanics culminate in Layer 4, the configurable partner program layer. This stack visualizes the complete architecture. Data flows upward from corporate ledgers, through the rewards oracle, into the central engagement score, to the utility token layer. Points from airlines, neobanks, and retailers feed read-only streams here, converging to unlock a singular, highly liquid token. That token has immediate usage-first applications. It provides access to premium node dashboards, discounts on cross-border payments, and priority allocations in real-world asset tokenization events. For the corporate partner, the return on investment is precise. They achieve highly cost-efficient engagement, funding rewards only when users execute proven, high-value on-chain behaviors. Because the architecture requires zero migration, the deployment is exceptionally fast. Partners can pilot a sandbox campaign contract with a limited token pool in weeks. The resulting data artifacts are fully verifiable. The partner sees exact uplifts and app logins, definitive counts of new wallet creations, and average transaction sizes recorded immutably on-chain. The Sigma BankAi framework bridges the scale of Web 2 legacy status with the economic efficiency of Web 3 utility. Corporate brands gain the programmable power of the blockchain, leaving the systemic risks of direct token migration behind.